Hi there! Welcome back to another Roots of Unity video. I'm Humayra, and today we will be sketching rational functions. So let's get started. Now here is a very familiar curve. Now why does y equals to 1 by x end up with a curve like this? You'll notice that as we increase the values of x from 1, the value of y decreases and gets very close to 0. But no matter how much we increase the value of x, the value of y will never be 0, which is why the curve doesn't touch the x-axis. Now again, as we decrease the value of x from x equals to 1 to x equals to 0, the value of y increases. And at x equals to 0, we end up with y equals to 1 by 0, which is infinity. And since we cannot sketch the curve at infinity, we show that the curve approaches the y-axis. Now these two lines, y equals to 0 and x equals to 0, which the curve doesn't touch, we call these lines our asymptotes. Now y equals to 0 is our horizontal asymptote since it's, a horizontal line, and x equals to 0 is our vertical asymptote since it's also a vertical line. So let's try modifying our equation a bit. And here we have y equals to 1 by x minus 2. Now, we know that our denominator cannot be equals to 0, so x cannot be equals to 2. So we've established that for x equals to 2, we will not have any values of y. So x equals to 2 is our vertical asymptote. Now, again, we have to rearrange the equation and make x the subject. If we do that, we end up with x equals to 1 plus 2y by y. Again, we know that our denominator cannot be equals to 0, so y cannot be equals to 0, and y equals to 0 is our horizontal asymptote. Now all we have to do is sketch our curve. Now for this part, we'll be needing our calculator. Take your calculator and go to the table function and put in your equation. Now you'll see that for positive values of x, as it increases, the value of y decreases. And at very large values of x, y is almost very close to 0. And again, as you put in more values, you'll notice the general shape of the curve is very similar to our y equals to 1 by x curve. Now what is the only difference? By subtracting 2 from the denominator, we have shifted the vertical asymptote 2 units to the right. Now can you guess what y equals to 1 by x plus 2 might look like? Rule 1, our denominator cannot be 0. So x cannot be equals to minus 2. So x equals to minus 2 is our vertical asymptote. Rule 2. We rearrange the equation to make x the subject. So now we end up with x equals to 1 minus 2y by y. And then again, our denominator cannot be equals to 0. So y cannot be equals to 0. And again, y equals to 0 is our horizontal asymptote. Now rule 3. Use the table function in the calculator to figure out the general shape of the curve. And our curve will look like this. Now let's have a look at how we can shift our vertical asymptote. Now say we have y equals to x minus 1 by x minus 2. Remember, rule 1, our denominator cannot be 0, so x cannot be equals to 2, and x equals to 2 is then our asymptote. Rule 2, we make x our subject. So if we do that, we get x equals to minus 1 plus 2y by y minus 1. Again, y cannot be equals to 1 because our denominator cannot be equals to 0. So y equals to 1 is our horizontal asymptote. Now finally, we have to use the table function of our calculator to figure out the general shape of the curve. And our curve will end up looking something like this. Now an easier way to figure out the horizontal asymptote is to divide the coefficient of x with the highest degree in the numerator and the denominator. So for this equation, you'll see that the highest degree in both the numerator and denominator is 1, and the coefficient of x in both the numerator and denominator is also 1. So when we divide 1 by 1, we get 1. So y equals to 1 is our horizontal asymptote. Now why does this shortcut work? Say we have y equals to ax plus c by bx plus d. Now here a, c, b, and d are constants. And you'll remember that to find the horizontal asymptote, we rearrange the equation and make x the subject. So let's do that. When we do that, we end up with x equals to c minus yd by yb minus a. Again, we know that our denominator cannot be equals to 0, so yb minus a cannot be equals to 0. Now, what do we get when we solve that? We get y cannot be equals to a by b. So for a curve that has equation y equals to ax plus c by bx plus d, our horizontal asymptote will always be y equals to a by b. Now say we have an equation y equals to 5x plus 32 by 2x minus 3. You can just say by having a glance that x cannot be equals to 3 by 2 and y cannot be equals to 5 by 2. So what are our asymptotes? X equals to 3 by 2 is our vertical asymptote and y equals to 5 by 2 is our horizontal asymptote. Now we just dealt with functions which had equations y equals to ax plus c by bx plus d. And we saw how functions like this, where both numerator and denominator had linear polynomials, had vertical and horizontal asymptotes. But now we're going to be dealing with improper fractions. Now, what happens when we have a quadratic numerator and a linear denominator? So first of all, we're going to be looking at y equals to x squared minus 1 by x plus 2. And if you remember, our denominator cannot be equals to 0, so x cannot be equals to minus 2. So x equals to minus 2 is our vertical asymptote. Now the next step we have to do is do a simple division, and we will be dividing the numerator by the denominator. So let's go ahead and do that. And as you can see, we got the quotient x minus 2 and the remainder 3. So we can now write the equation of the function as y equals to x minus 2 plus 3 by x plus 2. And this is what 1 by x plus 2 looks like. And you'll notice that the value of gx will never be 0. So we can say that y cannot be equals to x minus 2. So for this curve, our second asymptote is y equals to x minus 2, and this is an oblique line. So we will be calling these types of asymptotes oblique asymptotes. And now finally, to sketch this, we have to use a table function, and we will end up with a curve like this. Now let's try sketching another curve. This time we have x squared minus 4 by 1 minus x. Now rule 1, our denominator cannot be 0, so x cannot be equals to 1, so x equals to 1 is our vertical asymptote. Rule 2, we divide to find the oblique asymptote. Now if we do a quick division, we end up with y equals to minus x minus 1 minus 3 by 1 minus x. So from here we can see that our oblique asymptote is y equals to minus x minus 1. So we sketch that, and rule 3, we use the table function to figure out the general shape of the curve. And this time our curve looks like this. So there you have it. So that is all for today's video. Thank you so much for watching. If you have any questions or queries, please comment down below. And if you thought this was helpful, stay tuned for my next video where I talk more about sketching curves. Have a great day.